Good morning to all. A course material on CE 3351 Surveying and Leveling, presented by R. Raju Gandhi, Assistant Professor, Department of Agricultural Engineering, Rogani College of Engineering Technology, Palkulam. Well traverse table. In surveying measurement, there are all possibilities for errors to creep in, irrespective of the precaution and precision exercised. This necessitates a proper control, assessment, and distribution of errors. Error, mistake, and discrepancy are few times frequently encountered in surveying measurements. True error may be defined as the difference in measures and true value of the quality. When a number of measurements are to be fulfill a known condition, true error can be obtained. For example, the theoretical sum of exterior included angles in a traverse of n side is 2n plus 4 into 90 degree. Here, the error in the sum of observed angle is known, but the error in individual angle is not known. The observed difference between two like measurement, each of which may have an error of a quantity, is termed as discrepancy. A discrepancy should not be regarded as an error. A small discrepancy between two measurements does not reflect that error is small, where a large discrepancy indicates a mistake in the observations. Mistakes are the error arising from carelessness, inexperience, poor judgment, and confusion of the observer. Nature of error. Error in measurement may be positive if the measurement is too large, or negative if the same is too small as compared to its true value. Errors are classified as systematic errors and accidental errors. Systematic errors. The errors due to sag of a tab supported at its ends can be calculated and subtracted from each measurement. However, the tape can be supported throughout its length at short intervals, and the sag error may be reduced to a negligible quantity. It always has the same magnitude and sign, so long as conditions remain the same, and such an error is called constant systematic error. Whereas if the condition changes, the magnitude of the error changes and is known as variable systematic error. Accidental error. These are the errors due to combination of causes and or beyond the control of the surveyor. These can be positive or negative. Rose's calibration of a chain is an example of an accidental error. There is in reality no fixed boundary between the accidental and systematic error. Every accidental error has some causes, and if the causes were perfectly understood and the amount and sign would be determined, it would cause an accidental error but would be classed as systematic. Laws of accidental errors. Accidental errors follow the law of probability, and it is because of these accidental errors are known as probable errors or standard errors. This law defines the occurrence of errors, and when expressed in the form of an equation, it can be used to compute the probable value of probable precision of quality or quantity. The probable error is the number of errors numerically greater than it is the same as those less than it. It is always written after the observed quantity with the plus and minus sign as a measure of the precision of an series of observation and as a means of assigning weight or two or more quantities, and thus to find the weighted mean, the most probable value of each. Principle of least squares. The principles of distributing errors by the method of least squares is of great help to find the most probable value of quantity, which has been measured for several times, perhaps by the different method and different observation, and is calculating the trustworthiness of such a value. In the method of least squares, a descriptions of error of the discrepant observation are assumed to be accidental nature only. According to this principle, the most probable value of quantity is the one for which the sum of the squares of errors is minimum. The main objective of the method of least squares are determine the best value which can possibly be obtained from a given set of measurements to determine the degree of dependence which can be placed upon these values to enable us to trace to their sources the various errors affecting the measurement and consequently to increase the accuracy of the result by a proper modification of the method and the instrument used. Thank you.